All right, good afternoon, AP Calculus class. I am beginning this video that I talked about in class, essentially trying to summarize a lot of the concepts that we've been exploring the past week, right? Um, it's been challenging, but we've been relating basically f of x with its derivative and even at times taking into consideration its second derivative. Now, the idea with all of these is that they are related somehow. So they're all related. What I want you to do today with this video is not necessarily copy down word for word, but write down as much as you can of what I'm writing down in this video. But more importantly, as you're copying down the notes, don't just copy them down blindly. Think about what you're writing down, and try to have some takeaways from it that you can apply not just to this video, but to problems in the future, right? So I'm going to try to break this down as simply as possible. I'm not sure how successful I'll be at that, but I will try my best. So let's first look at a graph of f of x, right? This is a graph. I'm starting off very simple, right? Just a graph of a function. Now, visually from this function, I can identify a few things, right? On this function, I have, for example, this is a maximum, max, right? And this right here is a minimum. Let's see, what else? I'll say from here to here, my function is increasing. Also, apologies, at times I may struggle with labeling this because I only have a mouse. I wanted to use my stylus, but I did not bring it. So increasing. This middle part here, you can see the function is decreasing, which literally means it's going down. And then this final section, you can see my function is increasing, right? These are all features of my graph f of x. Now, why is this important, basically? Or why, knowing these features of f of x, do I care about f prime of x and my second derivative f double prime of x? Well, the idea here is that I can actually use my first derivative to tell all this information, right? So my derivative graph, we did the first derivative test. I would be able to tell where my function f of x is increasing, the maximum, minimum, all that sort of stuff without looking at the graph, right? And why is that? Well, let's clarify my relationship of f of x with f prime of x. So this graph, this one right under, I'm going to focus on this as f prime of x, or the first derivative, right? And I'm going to type this part. What is that relationship, right? That gives me all this information. Well, for the graph of f prime of x, what directly is the relationship? Well, essentially, the y value of the first derivative is always going to be equal to the slope of my original function, right? So that's what I tried to emphasize today in class, right? The y value of f prime of x is my slope of f of x. And this next part, you don't necessarily have to write down. I'm probably going to erase it in a second. But this actually gives me a bunch of info, right? So I'll say f prime of x actually gives me a bunch of info about f of x because of that relationship, right? So I can tell my mins, maxes, increasing, decreasing, etc., all that sort of stuff, even if I don't have f of x, right? Even if I don't have f of x, if I only have f prime of x, I can still tell a bunch of information about f of x, right? So, and the reason I can tell a bunch of information, again, comes down to this relationship. The y value of f prime of x is equal to the slope of f of x. So let's actually really concretely iron that down, right? So I'm going to now draw this. So let's see how I can illustrate that relationship, right? First, let's say I want to draw f prime of x, right? and I have this relationship. The y value of f of prime of x is equal to the slope of f of x. Well, I'm going to go back to my f of x. I'm going to erase some stuff. Actually, I'll leave it there. So I'm going to first look at this maximum, right? This maximum, I'm going to ask, what is my slope of f of x at this point? My slope is equal to, so I'll even write this as my slope is equal to 0, right? It's at the highest point. If I were to draw a tangent line, a line that's parallel to the function at this point, it would look sort of like this, right? So my slope is a flat line, it's 0. The function is flat at the very top. Same thing down here. My line is 0. My slope is 0. Right? So that is a great starting point for drawing my derivative, right? My slope of f of x is going to be equal to my y value of f prime of x. So on the f prime of x graph, at the same sort of point, I'm going to say the point's like right here, maybe around right here, right? I'm going to draw instead of the slope being 0, it's now a y value that is 0. So my y value being 0, this is my y-axis. My y value being 0 is going to be right here. All right. At this x value, I said my slope is also 0. So on my f prime graph, my y value is also going to be 0. Right? Cool. So that's some information I've garnered. Let's look at, I'm going to draw, let's look at this part of the graph. All right, that part of the graph now. All right, the part I just circled in green. Okay, so looking at this part of the graph, think about for a moment. So like I said, don't just copy down what I'm writing. Think about for a moment, what is the slope of this area of the graph? Right? Take a moment, think about that. You can pause the video if you want. So I would say this function is going upwards, right? So your slope is going to be positive. Right? So corresponding with that positive, for this same section of the graph, right? That's like this area right here. Between here to the left of this, right? Think about what your y values would be. Right, we said my slope is positive, so my y values are going to be, try to draw that out. My y values are also going to be positive, so they're going to be somewhat above the x-axis, right? They're going to be positive, something like that. And other information I know is that my slope actually goes from positive and it eventually becomes 0, right? My slope eventually becomes 0. You can see because my slope is positive, then it goes to 0. So I'm going to reflect that here. My y values are positive and they slowly become 0. All right, my y values slowly become 0. All right, so I'm going to label this as y is positive. Actually, at these 2 points, I should have labeled y is 0. Y is 0. Cool. Let's look at this middle section here, and I want you to start thinking about this. What is my slope here? What is my slope there? And I put a question mark. Cool. Once you have an idea of what the slope is, I want you to pause the video and draw what you think the slope might be on your actual derivative graph. Or sorry, what the derivative graph might look like. Remember, your slope of this graph is equal to the y value of this graph. Okay, once you've thought about that, I'm going to give you my answer. So for me, the slope here is negative, right? And the slope actually, it starts at 0. It sort of goes negative, right? Because it starts decreasing. And then my slope sort of eventually goes back to 0. Right, you can see that here. It's a 0 slope here, then it starts decreasing, then my slope goes back to 0. So I'm going to reflect that with my y values. My y values start at 0, and they sort of go negative. So my y values go to -2, and then eventually they have to come back to 0. So y is equal to negative in this section. All right, finally, this last section here. You think about this for a moment. This last section, what is my slope? Right, what is your slope, and how would you reflect that on a graph of your derivative? Okay, my answer for this part is going to be, well, my slope is positive. And to become positive, I start off, my slope here is 0. Right, actually, I'll draw that cleanly. My slope is positive, but it started off as 0 and transitioned to being positive. So same with my y values. My y values are going to start at 0, and slowly my y values get more positive. Right, so I'm going to write my y values become positive. All right. So that is how I draw my derivative graph, is constantly thinking about this relationship. All right. Another thing you might note is that your x values stayed consistent. So what I mean by that is, let's say, for example, here, right, this is an x value. Let's say this is an x value of 2. And what did I say? At x equals 2, my slope is 0, right? Well, that was also reflected here. My x value is 2. And that's why my y value is 0, right? X value is 2, my slope is 0. Well, in my derivative graph, x value of 2 means my y value is 0. All right. Hopefully that takeaway also sort of makes sense. I'm going to move on now to my next graph, where I'm going to now relate us to the graph of f double prime of x. All right. And with double prime of x, let's not overthink this. I think it can start to get confusing because we brought in the word concavity, but a better way to perhaps think about it is this is just one more derivative. I'm just taking one more derivative. So what does that actually mean, right? One more derivative. Well, I can say this, right? Since the graph of f prime of x means the y value of f prime of x is the slope of f of x, if I just took one more derivative, that means the y value of f double prime of x, so my second derivative, that's simply going to be the slope of my first derivative. Right, so it's the same exact relationship. The y value of my second derivative is the slope of this graph, slope of my first derivative. Right. So now I'm basically going backwards one function, doing this whole slope idea again. Right. Now, let's actually do that really quick. Let's just plot that. I will go back to, say, green color. Okay. So again, the y value of my second derivative is the slope of my first derivative, right? Because it's just related by one derivative. Let's look at my first derivative. First derivative, this section here. Actually, I'll start with the lowest point. These are always good to point out. My minimum here, what is the slope at this minimum? Think about that for a moment. All right, yeah, our slope is going to be 0. Okay, so that means on my second derivative graph, the the slope was 0, that means my y value is equal to 0. Right, so it's the same exact relationship we were just drawing. All right, let's look at this whole section of graph right here. Someone tell me, or draw this yourself, what is the slope of this section of the graph? I would say from around from -5 to 0, what's going on with the slope? Right, for me, the slope is negative because the graph is going downwards, it's decreasing. So the slope is negative, and it's negative. Eventually, the slope becomes 0, though, right? So the slope eventually becomes 0. So same idea here. My y values are going to be negative, right? Let's say they start negative, but they slowly go to 0. And also, yeah, this section of the graph starts at -5. So remember, my x values stay consistent. So I start at -5, and my slope is negative, but it slowly goes to 0. So negative, and it slowly goes to 0. Right? And I'm reflecting this again in my y values. So my y values are negative, but they slowly go to 0, just like how my slope here was negative, but slowly goes to 0. All right, next section of the graph starts from, I'd say, 0 and goes to around 5. What is my slope for this section? Think about that for a moment. The function is going up, so I would say my slope is positive, right? And my slope, in this case, it starts from 0 and it goes positive. So my graph here, my y values are going to start from 0, and my y values are going to go positive. And I end at 5 because that's where my graph ends. And I end at 5, the corresponding slope. Again, I plot the slope here that are positive with the y value here that is positive. Right, so I'll say my y values here are positive. All right, so as you can see, now I have my derivative graphs drawn. All right, so we've successfully completed one task, right? Which is essentially I've drawn my two derivative graphs. I've gone all the way down, right? I drew the slopes of this graph as the y value of this graph. Then I took the slopes of this graph and I drew the y values of my next graph. I could keep going down the line and keep on going through derivatives, right? Now, there's a few other takeaways I want to talk about. So the y value of f prime double prime of x is not only the slope of f prime of x, it's useful in of itself because it gives me information on f of x. So let's clarify that relationship. The y value of f double prime of x is actually going to also tell me information about the concavity of f of x. So it gives me info on, I'll say, one graph ago, right? Right. Obviously, the y value of this f double prime of x gives me the slope of f prime of x. That's a very clear relationship that I've talked about a lot at this point, right? But the reason we look at two derivatives is because it's useful in of itself in giving me information on two graphs ago, right? Two graphs ago, it gives me information. So now we've done that, and I want to now work backwards a little bit, right? And try to iron out a few questions, right? So if I were to ask, based on this graph, and here's like really sort of where I want you to test your understanding a little bit, because we've drawn the graphs, right? So I'll say test your understanding. My first question is going to be this. Based only on f double prime of x, based only on this graph, where is f prime of x, I'll say, increasing, right? So based only on this graph, so don't even scroll up at all. I'm not going to scroll up, right? Where is f prime of x increasing? Okay. And to help define this further, f prime of x would be increasing when f prime of x has a positive slope, right? That's the definition of increasing. Its slope would be positive. So where f prime of x has a positive slope. Right, so you can let the video run because I'm gonna give you a moment to think about that. Where does f prime of x have a positive slope? Where is it increasing? Well, the answer to that, and I'm gonna give some context before I answer. Right. And it's gonna be based on this. Well, when the y value of f double prime of x is positive, that means the slope, positive slope of f prime of x, right? Which means it's increasing. Right, so where is it actually increasing? Well, when my y values are positive, right? My y values are positive from 0 to 5, right? So that would be my answer. Based only on f double prime of x, where's f prime of x increasing? Well, f prime of x would be increasing when f double prime of x is positive, and it's positive in this section right here, actually, that it conveniently highlights for me. So, question, based only on f double prime of x, actually, I won't even say that. So where is f prime of x decreasing? Where is f prime of x decreasing? Right. The answer, here I might ask you to pause for a moment. After I ask these questions, pause, see if you can solve them yourself. The answer is going to be from -5 to 0. Right. Couple more questions I can ask. Question, where is f prime of x? Where is the slope of f prime of x? 0. Well, remember, I plotted the slope f prime of x as y values. So the answer is going to be when my y value of f double prime of x is 0. And where is my y value 0? Well, right here at x equals 0. At x equals 0. Yeah. Cool. Right. Now, I'm going to go backwards really quick because think about another way I can ask this question. Where's f prime of x decreasing? Another way to ask this question is, this is the same, or not another way to ask this question, but another question I'll ask is, where is f of x concave down? And now I'm testing this other relationship, right? We were just looking at this relationship. The y value of this, the y value here is going to be the slope of f prime of x. I'm not testing this relationship. The y value of this is the concavity of f of x, right? Well, where's f of x concave down? Well, the concavity of f of x is determined by the y value here. So its answer is also -5 to 0. All right. So in a way, these are actually mathematically the same question. Where is f prime of x decreasing is the same as where is f of x concave down, because it's the same sort of relationship. Right? F prime of x gives me the slope of f prime of the y value of f double prime of x gives me the slope of f prime of x. The y value of f double prime of x gives me the concavity of f of x. All right. Another question. Right. Where is f prime of x increasing? Where's f prime of x increasing tests this relationship. Where is f of x concave down tests this relationship. Where is f of x concave down? That tests this relationship. Where's f of x concave down? And the answer, oh, sorry, concave up. I apologize. I am not thinking. So where is f of x concave up? Well, the concavity of f of x is dictated by the y value of f double prime of x. So all these positive y values means it's going to be concave up. So my answer is also 0 to 5. All right, hopefully that makes sense. Let's keep on going backwards and ask some questions about f of x now. And I want you to try to answer these. Okay, question. Where is f of x decreasing? aka negative slope, right? Where is f of x decreasing? Well, let's think about what our relationship is, right? So I'll pause. You try to answer this. You try to answer this. Okay. So hopefully you've tried to answer it. Where is f of x decreasing? Well, remember, how can I tell this? Where is f of x decreasing? Where does it have negative slope? I can tell this based off the y value of f prime of x. So the y value of f prime of x is negative here, between -2 and 2. Right? -2 and 2. Cool. Question, where is f of x increasing? aka positive slope. Well, where does it have positive slope based on this graph? Well, it has positive slope when the y values are positive. Well, my y values are positive in this section, also in like this section over here. So I would say between this section is, let's say between -5 and 2. Also, that's union with this next section, 2 to 5, 2 comma 5, right? That's where f of x is increasing. And I can tell that based only on this graph. All right, let's ask some more questions. I'll say, where does f of x have a relative minimum? Right, where does f of x have a relative minimum? Okay, and let's think about what happens at a relative minimum, right? At a relative minimum, you can see what I drew right here. What color should I use? I'll use red. You can see, oh, yeah, I have a minimum right here. What happened at this minimum? Well, my slopes went from negative to positive, right? My slope went from negative to positive. So I'm going to look for where my y values go from negative to positive, right? Remember, the y values of this reflect my slopes of f of x. So my y values go from negative to positive at 2. So the answer is going to be at x equals 2, right? So it's going to be right at this location. And remember, don't get it twisted as in you look at this and be like, that's not a minimum. Remember, f prime of x is giving me information on the slope of f of x, so I can tell info about f of x. And at 2 for f of x, I have a minimum, right? And I can tell that without even looking at my graph, just looking at my derivative chart, my derivative graph. All right. Question, where does f of x have a relative maximum? Think about that for a moment. Try to answer it yourself. Where does it have a relative maximum? Based on this graph. And it's going to have a relative maximum at, and hopefully you answered it, at x equals -2. And the reason it has a relative maximum at x equals -2 is because the y values here go from positive to negative, right? Positive to negative. And my y values are the slopes of f of x. So basically my slope of f of x would have gone from positive, so it's increasing, to negative, decreasing, which created a max. Right? Okay. Let's think about, here, I'm going to erase some of these and answer a couple more questions. Let's think about now the relationship between f of x and the third graph, right? f double prime of x. So where's my second derivative? I'll say, where's f double prime of x negative? Right, where's f double prime of x negative? We should be able to answer it just off this graph. Well, remember my relationship, right? F double prime of x is the slope of f prime of x. So f double prime of x is negative when what? Well, when my slope of f prime of x is negative. When slope of f prime of x is negative, right? So I can actually tell a lot of information. I can actually tell f prime of x is negative, or sorry, the slope of f prime of x is negative from, I'll say, -5 to 0, right? So my answer here is -5 to 0. Question then, where is f double prime of x positive? Think about that for a moment. Pause the video. All right, I'm going to give you the answer. It's positive from 0 to 5 because f double prime of x, again, represents the slope of f prime of x. And the slope of f prime of x is positive from 0, I'd say, all the way to 5. Okay. So you can see, based off one graph, I can answer a bunch of questions, and more importantly is understanding the relationships between the two, right? Now, if you're ever confused or get lost, always come back to what I'm going to highlight here. The y value of f prime of x is the slope of f of x, right? And also, I can say the y value of f double prime of x would then be the slope of f prime of x because they're related by one derivative. And the y value of f double prime of x is the concavity of f of x. That is a two-derivative relationship. All right, hopefully this helps. Yes, just turn in your notes via Google Classroom.